Hello everyone, welcome to Everything Building Envelope. I'm your host Paul Beers. Everything Building Envelope features topics of interest related to the exterior building envelope, including waterproofing, glazing, cladding, and roofing. Please visit our website, everythingbuildingenvelope.com, where you will find access to each episode along with show notes and a special video section with bonus content. Please subscribe to the Everything Building Envelope podcast on iTunes and Android outlets such as Stitcher. So we've got a topic today that I'm really excited about, field water infiltration testing. Maybe it doesn't sound so exciting, but believe me, it is. And we've got a really great guest, Will Smith. So Will and I have worked together at GCI Consultants. Will, long time, huh?
Yeah, don't say how long. You're going to let everybody know how old we are.
We didn't have gray hair when we started doing this. So, Will, you've obviously, from our experiences together, you've been involved in all aspects of our consulting business, and even before that, you had some great experience. So maybe you could just kind of clue the listeners in a little bit about your some of your background and experience.
Sure. And first, let me say I'm really glad to be here today to talk about this topic. I do have a lot of experience. I've been involved in construction since 1971, quite a few years. And over the years, I've developed several different types of window and glass systems, including the testing that was done for those systems for certification, as well as field testing after installation and field testing forensic installations. I've done a number of projects all over the United States, in addition to just water testing that have involved exterior wall systems, curtain walls, storefront, stucco systems, roofing, virtually all types of building envelope components over the years, including testing of those products.
And you, with all your travels around the country, a lot of times it's involving disputes, is that right?
Yes, quite often.
So, and then of course, disputes equals litigation, so you've been involved in some. Actually, I know this already, but the listeners may not. A lot of construction litigation and issues around performance and testing and things like that.
Yes, performance of buildings oftentimes requires that people want to know why it's not working, and that's the whole idea of the forensic examination, is to find out what's wrong, and which often involves not only water testing, but destructive testing to uncover the problems and determine the source.
So testing forensically, is there other ways that testing is used aside from just trying to chase leaks around?
Yes, and I'm glad you asked it, because really the listener needs to know there's really only two basic reasons for doing water testing of the exterior building components. There's several different causes, but they all fall down into, or can be categorized into two different areas. One would be new construction, or shortly after new construction, where testing is done in order to determine whether the products that are installed were installed in such a manner that they're able to perform as they were intended to perform. So that would be a performance evaluation. The second purpose for testing is sometime later, when the building begins to experience some type of leakage or other problems, and you want to uncover what the cause of those problems are. Testing is often a very, very important part of that examination in order to confirm your theory of what's going on, what the problems are in the building.
So when you say water testing, is it somebody taking a hose out and spraying with the building, with a nozzle, or is there other ways that it's done?
Well,
try not to laugh. I'm sorry.
Unfortunately, that happens all too often. it is kind of comical when folks go out with a hose and decide that they want to do testing. Again, getting back to the purpose of the testing, that the purpose of testing is either to demonstrate the ability of the product to perform, and there are standards that come into play which are used by industry in order to demonstrate that. And even from forensic analysis, where people say, okay, well, I know I got a leak in the building, let's just put a hose on it. Well, even then, there are standards that come in play that tell you how to do the testing, and the reason is that you want to do testing in such a manner that it can be reproduced. And what I mean by that is if it's an existing building, for example, the owner needs to have some assurance that the testing is done in a method that reproduces the problem that he's experiencing in the conditions. Weather conditions that occur when he experiences that problem. For new construction, however, it's a little bit different. You're testing to a performance standard, so the performance standard tells you how to do the test, and it's not with a hose. It's done in a method that is, again, it's a procedure that anybody can go out there with the right equipment and reproduce that test and should be able to get the same results.
So we're going to talk about some of these test standards in a minute. But just to follow up on what you were saying, in the new construction scenario, do you find that the field testing simulates what the product may come upon later on in real weather conditions?
Well, possibly, but not necessarily. For example, all too often people buy new windows and doors, particularly down here in South Florida, where they buy what they call a hurricane window or a hurricane impact window or something like that, and it's been tested to certain standards. But the standards for water resistance do not necessarily mimic the conditions that would be experienced during a full-blown hurricane. For example, when testing is done, whether it be in a laboratory or out in the field for impact testing, and they do water resistance portion of that test, the water is applied at a certain pressure for a certain period of time, but that is done because that's what the standard tells you need to do. In the real world condition, hurricanes are not that predictable, and the wind speeds in a hurricane are not that predictable. The directionality of the wind is not that predictable. So they have the standards that can be used as a guide, but it's not all inclusive of every condition that may occur.
What about like with just regular weather patterns in a given area, assuming that the spec was put together correctly?
If the spec is put together correctly, that we're talking about the specification that was put together by the architect and in the project documents, then yes, under most conditions, the testing that is done in a laboratory would fairly represent the type of conditions that are going to be experienced out in the field.
And if you go through a testing program in the field during construction, and let me ask you this. Is it common or uncommon for in construction, new construction testing to have a failure while the building's being built?
It's quite common.
Yeah. And what happens if you do have a failure?
Well, that's the beauty of doing the testing out in the field during the construction process, is that it allows the installer and the manufacturer to go out there and address those problems. And obviously, from the building owner, architect standpoint, the earlier you can do that test during the construction process, the earlier you find the problem, and therefore are able to address that problem and eliminate that for any future work that's done on the job.
So you go through the process during construction. Maybe you have some failures, maybe you don't, but you go through it. and you end up, with so basically the goal is at the end, correct me if I'm wrong here, is to have everything, the stuff that you're testing at the end is all passing the test.
That's the goal, correct.
Yeah. And if that's not happening, then what should you do?
Well, again, the manufacturer and the installer need to work out these problems. They need to investigate the problems and inspect them. Now, the standards are written in such a way that it says, if you do the testing for new construction following the standard and it does not pass, then the installer and the manufacturers are supposed to correct those problems so that future testing can be done. And if it continues to fail, then you need to do a diagnosis according to another standard, which is kind of like a forensic analysis where you start to actually take things apart and find out exactly what the problems are. Again, the purpose is to address those problems so you can catch them early and take care of them in the balance of the job.
And ultimately, you're going to be, to have a successful program, you're going to be doing tests, have tests that pass in the end, correct?
That's ultimately you end up with them having passed the test, correct.
And so given that scenario, can a building owner have confidence at the end of the project that, not to say that there's not going to be any leaks at all, but they're not going to have a chronic leakage problem if they've gone through all this?
If they've gone through this, they should have some assurance, or they're giving the assurance that the product they have was installed in such a manner that they should not be experiencing chronic water leakage problems. But that does, as you well know, nothing is permanent. Everything needs to be maintained and kept up. So windows, doors, wall systems, sealants, all of that stuff needs to be inspected on a regular basis by a qualified inspector to make sure that they are able to continue to perform as the building ages.
Yeah, it makes a lot of sense. So let's do the interesting part now and talk about all the standards.
Yeah, it's like watching grass grow.
Right. So we talked about, using a hose, but really that's probably not the way that it's normally done in most scenarios. Would you agree with that?
I would hope it's not. That's great.
If you see the hose, then that's when all the alarm bells should be going off in your head.
Right.
So I'm just gonna. So I've got these standards: ASTM 1105. I'm a 502. I'm a 501.2. Let's just kind of go through and let's start with ASTM E1105. This is you'll tell us, but I think it's kind of the basis for everything else, is it not?
Yeah. This is a particular. This standard was written for field water testing of windows and doors. Originally, since its initial implementation, which goes back, frankly, decades, it's been revised and updated a number of times, but the basics still remain the same, and it's become so widely accepted that it's used for testing not just windows and doors anymore, but for exterior wall systems, and variations are used for a number of different construction materials. The objective or the manner in which the testing is done is that it applies a uniformly distributed, or you have a grid pattern, if you will, that applies water in a uniform manner across the exterior surfaces. And then while that is done, you can create a negative air pressure on the inside of the building, which then forces air from the outside of the building to the inside, which replicates the effects of a wind-driven rain.
And how do you create this negative air pressure difference?
Well, there's several different ways, but the most common method that's done is you build a temporary wall on the inside, which is called the chamber. You build this wall and you seal it off on the inside, and then you evacuate air out of it using exhaust fans. So it creates this negative pressure on the inside of the material that you're testing versus a regular ambient pressure on the outside of the building. So you're forcing air from the outside to in. Now, the one thing about the standard that people need to recognize, though, is that ASTM E1105 tells you how much water to apply, how to create the pressure differential, but it does not tell you how much pressure differential to use. And again, like I said, the pressure differential is what simulates the wind in a wind-driven rainstorm. The more pressure you use, the higher the wind, and the more likely you're going to have water be forced from the outside to the inside of the building. But that standard does not tell you what air pressure to use.
So how do you figure that out then?
Okay, that comes from another standard. If you're testing windows and doors, which is something here at GCI that we do very frequently, and it's in a new application, new construction, the most commonly used procedure is it's AAMA 502. AMA 502 gives you the formula to use, which is based upon the certification that was obtained by the window and door manufacturer when they first submitted their products for laboratory testing. Basically, what the AMA 502 says is in the field, you use 2/3 of that pressure that was created in the laboratory test. That's what you use in the field test.
Does this somehow relate to building codes or structural design, or I mean, what's the how do you come up with the number that you would use on a given project if you were the specifier?
Yes, there is a tie back to the building codes. The building codes require that exterior windows and doors in buildings need to be tested in a manner as specified in a document called AMA 101. AMA 101 has got several more initials there that I'm skipping over, but AMA 101 tells manufacturers basically how they're supposed to build windows and doors and what the testing criteria needs to be, how they test them in a laboratory setting. Then in the field, when we're doing field testing, that's when you go to the AMA 502 that we were just talking about, and it uses a percentage of that test that comes from that was done to comply with AMA 101.
So can you talk about the what comes to mind now is with test pressures is 15% and 20% of the structural design load. Can you just talk about that a little bit?
Yeah, it gets again, it gets overly confusing, but
let's keep it simple though.
Well, again, going back to that document AMA 101, which is referenced in the building codes. The building codes also say that windows and doors have to comply with the wind pressure standards that are included in the building code. So when you test in the laboratory for certification of a new window, the window manufacturer needs to test it for pressures, for wind pressure only, plus they have to test it for what's called a structural test pressure, which is 150% of the normal wind pressure. And by the way, the wind pressure is calculated based upon the requirements we talked about a second ago in the building code. So let's say that the building code, after you do your calculations, you find out that you need to test that window to a pressure of, we'll make it an easy one, let's say 50 pounds per square foot in pressure. That's wind pressure only. Then you need to do a structural test pressure, which is 150% of that, which would be a test of 75 psf instead of 50 psf. Then water infiltration resistance, according to the standard, needs to be done at 10% of the structural test pressure or 15% of the design pressure. So a 5 pound, or excuse me, I said that wrong, a 50 psf window would be tested at a water test pressure of 7.5 psf. Now, when you go into the field during new construction and you want to test according to AMA 502, AMA 502 says you take that 7.5 and you reduce it by a third to get to the water test pressure that you should be using in the field. And the reason they say you need to reduce it by a third, is simply because that when the manufacturer tests their products in a laboratory condition, everything is perfect. The test chamber is set up perfectly, the test specimen is set up perfectly, the conditions inside the laboratory are perfect, the window is installed perfectly into the chamber. But when we get into a new construction job, there is nothing that's perfect. No wall is perfectly straight and plumb, and so they know that there's going to be variables that just simply are going to occur, and that was the reason for coming up with the 1/3 reduction.
So, we get asked this question a lot, and I'm going to ask you the same question. Why do you need to do field testing if they test the windows in the laboratory?
Because, as I just said, when it's done in the laboratory, this is something that's required of the manufacturer for certification. When the manufacturer sends their products over to the laboratory in order to be certified, they send their installers and their laboratory personnel from the manufacturing plant to an independent third-party laboratory, and they install that window, again, in perfect conditions, in a perfect situation. So when you do it in the field, as I said, nothing's perfect, and you have installation variables. In addition, when you get into the field, you have other components that come into play. Remember that in the laboratory, the manufacturer is required to test only the window. They seal that window to a test buck, if you will. It's a bunch of 2x4s or 2x10s or whatever. And they attach the window to that and they seal it to that. But this is not a wall. This is not a wall with stucco on it or siding on it or a weather barrier on it. And all these other things become part of the final installation and the final building envelope. So when you're testing out in the field, you're looking at more than just the window. You're looking at the integration of that window into the wall system, and you want to make sure that everything's working together, not just the window.
We've talked about E1105, ASTM E1105, AMA 502. So the how to test the window and how to figure out what performance criteria to use when you're testing it. Is there also we were making jokes before about nozzle testing. Is there also a nozzle test that people use during the construction process?
Well, there is. I joke about using a hose and a nozzle, but there is actually a nozzle test out there, but it has a very specific purpose. And I need to qualify that. I called it a test. If you read the document, it's not even called a test. It's called a field check. It's a quality assurance check. And that is a procedure. It's called AMA 501.2. In 501.2, you use a specific size hose with a nozzle that is a specific nozzle made by a specific manufacturer. It's a Monarch number 6 nozzle. And you apply the water at a certain rate and flow rate. You have to have a gauge on that nozzle so it measures how much water is going through. But if you look at the document, it says it's a test for quality assurance, check for the installation of new storefronts, curtain walls, and slope glazing systems. And in fact, in the introduction to that document, it says, do not use this test for operable windows or doors. It's intended only to be used for those types of glazing systems that remain permanently fixed and closed. So some people attempt to justify doing it out in the field by saying, well, we won't use as much pressure of water coming out of the nozzle, or we'll stand farther away from the window when we do the test, or there's a whole host of things that people try to use to justify the use of it. But the there's a very specific reason why that test should not be done on operable components, and that is because operable components use different types of gaskets, weather strips, and water-resistant materials that are easy to overcome when you apply the water from a certain direction. For example, when you do the testing we were talking about earlier, where you have an even distribution of water over the surface of a window, that uniformly applies the water, whereas in AMA 501.2, you can spray this. A man could stand in front of a window and hold the hose and point it up to the top of the window or the door and get water to come over the top of the door and say, well, see, it failed. And I've seen this done. But the fact is that water doesn't rain up. Water falls down. So yes, I can use that test and make it leak, but that doesn't mean it's representative of what would actually occur. And that's why AMA 501.2 says don't use this on those types of products.
So here at GCI, what do we typically recommend when it comes to field testing?
We recommend or field testing of new installations, new construction. We recommend testing according to ASTM E1105, the document that we talked about earlier. And we also recommend to the client, whether it be the architect or the building owner, to follow the guidance that's offered in AMA 502. But if they want further assurance, they can, in a new construction project, as long as they write the specifications clearly so that all the bidders know right up front, they have the option of omitting the 1/3 reduction, or they can test at any pressure less than the actual certification pressure if they're looking for additional satisfaction out in the field, or a comfort level out during the field installation test. But it's very important that that information is provided to the contractor and the bidders up front in the specification process, not sometime later that it's sprung on them and they suddenly have to provide a product and an installation that they didn't know about.
So you're saying, for instance, if you had a high exposure project, say a multi-million-dollar oceanfront condominiums, that maybe just to use an abundance of care, it may be appropriate to specify a higher test pressure than what's found in AMA 502.
Correct, and in fact, for example, take your example one step further. Let's say that we have a building, a high-rise building, where the structural pressures for that building, the design pressure for that building is, they got some doors with 100 PSF design pressure requirement. Well, in the laboratory, normally what would be done is you'd say, okay, well, we need 15% of that for our water test pressure, so that would be 15 PSF in the laboratory. However, if AMA 502 has a limitation of 12, so they may only need to test up to 12. But some manufacturers say, okay, we're going to go beyond that and we'll test to 15. So they do that actually in the laboratory and test to 15. But then you go out in the field, and normally following AMA 502, you would reduce that by 1/3 and test at that lower pressure. But the owners of this high rise may experience much higher pressures in the real world. So the specifications can be structured in such a way that you can specify that higher pressure right in the specs up front and bring it out to the attention of the bidders, so that there's no question when the time comes that you do a verification testing in the field that they know that that's what they got to satisfy.
Are there test standards for, I guess what I call remedial testing, or when you have a building that's leaking, to try and figure out what's really going on?
Yeah, that's a forensic examination. And actually, there's a standard out there, ASTM specifies or publishes a standard called ASTM E2128, which is examination of water leakage in building walls. By definition of that standard, building walls includes windows, doors, and any other penetrations that go through the building wall. And again, here the objective or the understanding is you're out there as a professional, as a testing laboratory or a consultant. You're out there to find the problem, to track it down. And there's a section in ASTM E2128 that specifically addresses testing. There's a number of different steps you need to go through for compliance with this standard before you get to the testing, but testing is a very valuable part of that. And what you'll find when you read the testing section is it makes reference to these standards that we've already talked about. It references the ASTM E1105, it references AMA 502, it references AMA 501.2, the hose test that we talked about. It references a number of other different test standards that are all acceptable. And the reason they're acceptable is, once again, this is an examination that's a forensic examination of building walls and their components. So they have to include all these standards or make reference to all these standards because there's more than just windows and doors that may be tested. We're talking about stucco, we're talking about brick, we're talking about flashing assemblies, we're talking about fascias, roofs, soffits, stone. There could be a number of different things, so they don't specify or limit the type of testing. They just say that all of these need to be considered. The preface to all of this, however, is the testing section says it's critical that the testing agency reproduce the testing conditions that have been known, or reproduce the conditions that have been known to occur. That is, the winds and water conditions, the rainstorms, if you will, and then also reproduce the leakage that has been known to occur. And the reason that I point this out is the standard goes so far as to say, if you do your testing and you have you create a leak during your test, and there's no evidence that leak has ever occurred in the past. For instance, there's no water stain on the inside of the building where this water is appearing. There's no damage, no water path, nothing. The standard says, well, that's nice information to have, but that doesn't address the problem that you're out there to solve. You need to solve the water leakage problem that is being reported by the owner. So you need to uncover the leakage locations. You need to test in a manner that replicates the conditions and then reproduce those leaks.
So is there a way to figure out how to test to replicate the conditions?
Yeah, there is. ASTM, again, ASTM E2128, similar to E1105, tells you how to do the testing, but it doesn't tell you how to figure out how much wind pressure to use if you're going to apply wind pressure. And that comes, once again, from another standard. E2128 does say you need to replicate the conditions. They don't tell you how to do that. If you go to another standard, it's called AMA 511. AMA 511 gives you an appendix, and it's got formulas in the back that tell you how to get the information in order to replicate those conditions. And the basics of it are that simply you download or otherwise research the weather data that's available from one of the many weather services out there, for example, NOAA, National Oceanic and Atmospheric Administration. You download that weather data for that site or the closest weather station you can come to. Then you find out the average wind speeds during rain events at the time when the owner has experienced water leakage. You backtrack that. Maybe you'll go back a few years in order to get enough information, but you find out what those averages are and you use that for your test.
Wow. Sounds a little more complex than the new construction formulas.
It is much more complex, and that's the reason, and for that, because of that rather, that's the reason we see so many people out in the field just ignore that step and just pick a number and start testing whether it's right or wrong.
So you segue right into my next question. So you talked about how we do a lot of testing here at GCI. In your line of work, you get involved in a lot of projects that have claims and disputes and expert witness and stuff like that. And I know you see a lot of testing going on and all across the country, not just in Florida, but West Coast, Midwest, Northeast. You've been all over. Right? Your frequent flyer miles are. Most people will be very envious. I'm sure you're ready to probably not be getting so many of them at this point.
That's very true.
Yeah. So anyway, do people do this correctly? I mean, do they follow the standards? Do they get it right? What's your experience with that?
Some do, and it's always a joy when you see somebody who actually goes through the effort of researching the data and coming up with a pressure and with a test methodology that is representative of the conditions that actually occur, because I consider when they do that, that's a defensible position to be in, and that's a good position to be in when you've got the data to support what you're doing. But all too often, because it is a rather lengthy task and it does take a lot of effort in order to make that, come up with that information, I see people come in with, and they try and come up with information later that to justify what they've already done out in the field, and rarely does that work out. They instead go out there during the actual test, and they'll test at numbers that, frankly, I don't know where they come from. We see anything from people using pressures that are really limited only to windows to new construction. And we talked about new construction. There is, by the way, a very clear definition in the standard when it says for testing windows and doors that the new construction applies to windows and doors that are up to 6 months old. After that, it goes into the forensic type test. But we see people applying tests to windows that are 7, 8, 10 years old, using those standards that applied when the windows were brand new. And that's kind of like expecting your car to have the same performance when it's 10 years old that it did when it was brand new. That just doesn't happen.
So, do people? I guess I'll just ask it this way: Do people try to make windows leak sometimes rather than try to figure out what's really going on?
Well, I'm the eternal optimist, and I hope that's not the case. But sometimes I feel like that's exactly what's done. I've seen some examples of some testing that are downright laughable in instances where it's clear that the method that was used, not only is it a blatant misinterpretation of the standards, it's a violation of the test standards, and it's sometimes it would appear in an effort to make something that would not normally happen occur, and make what they call leaks, which are not really leaks, occur. I was looking at a test just a week ago where they were testing a window that was several years old. This is like 8 or 10 years old. And this happened to be not an aluminum window, but a wood window. And not only was it a wood window, but it was a wood window that the inside of it had never been finished. So it was just raw wood that the owner had never finished it. And during the test, they made water come over the top of the window sash and appear on the inside. Now, somebody would say they were all standing there saying, "Oh my gosh, look at this horrible leak." Well, the fact is, you can see there's not one stain, not 1 ounce of discoloration on the raw wood that's many, many years old. So clearly, this is something that they made occur. This did not recreate a condition. This did not solve the leakage problem. The owner never saw this happen before. He was standing right there and said, "I've never seen this." So it goes down in the report as saying it's a leak, but it's not really a leak. So it doesn't help the situation.
So give us a couple. Tell us. You said some laughable ones. Give us a laughable one.
Okay. A window, a series of windows. This was done in a case that involved a number of different properties all over the United States. And these were casement windows, operable casement windows. And casement windows is kind of like your car door, where your car door opens and it might have when you look at the edge of your door, you might see that there's some type of gasket or a weather strip on there. And then when you close your door actually closes up against a gasket that's permanently mounted inside the door frame. Well, the gasket that's in the door frame is what really stops the water. The one on the outside helps reduce the amount of water, but it doesn't actually keep you dry on the inside of your car. I saw repeatedly where the testing agency went out and used the AMA 501.2 hose test, which is, they say, do not use for operable windows and doors. They justified it by reducing the pressure from like 30 down to 5 psi of water pressure. And what they did was stood about 3 inches away from the outside face of the window and directed it right at the corner where these gaskets on the outside have an opening in them in order for the water that might be able to get past it and allow that water to get back out. Well, that's where they forced the water in. And then to top it all off, they had water paper, moisture detection paper on the inside that they fit in between the main gasket and the sash. And after their testing was done, they pulled it out and said, "See, the paper's wet, so it must be leaking." Well, what that is water that they forced in around the edge of the sash, is flowing down the side of the frame. It flows over the paper. It didn't go past the gasket, but it flows over the paper, gets the paper wet, and they claim this leaked. And this was done on dozens of properties all around the country and was used as justification for their report.
So, that's an example, it sounds to me like, of a litigation matter.
Yes, it was.
So when people improperly test, does it affect, can it affect the outcome of the litigation?
Most definitely. As an example, several years ago, I was involved in a case in which the owner hired a engineering firm to do testing of the windows and doors. They did, I can't tell you how many tests. They did dozens and dozens of tests. But they did not follow the standards at all. They tested at pressures that they selected, not at pressures that replicate conditions that have been known to occur. And not only that, they created leaks that, again, obviously, there's never leaked before. Ultimately, this went to trial. This was a case that there was more than just windows and doors, but the window and door portion was worth multi-million dollars. The entire case was over $30 million in damages, what the owner was claiming. And the testimony went very much against the plaintiff's expert, and they ended up getting a 0 verdict.
Because they didn't test right.
Because they didn't test right. The owners, or the jury, was convinced that the plaintiff's consulting firm had messed up and did not accurately portray the conditions that the owner was experiencing.
Wow. And so, have you seen things like, and throwing you a softball here, but have you seen people test with like fire hoses or pressure washers or things like that?
Yes, yeah, that's true. Unfortunately, there's a reason for the standards. We talked about that earlier, and the reasons are if you're experiencing problem in your building, and you're having water leakage in your building, you want to find out what the cause of that leakage is. It might be a window, it might be a seal somewhere around the window, it could be a stucco problem uh, somewhere outside of the opening. It could be a number of different problems, and the idea is to do the testing in a manner that can be replicated by virtually anyone as long as they follow these standards, and you have an assurance that what you're doing recreates the conditions that the owner has experienced on the job and the leakage conditions that he's experienced on the job. That way you're able to backtrack the water path through the building and find the source of entry. But not only can you find the source of entry, that allows you then to figure out the repair process. And that I want to highlight that because all too often, particularly in a forensic examination, what we often find is firms go out and they're hired to do testing. They do the test, they do it improperly, and the solution that they come up with is remove and reinstall all the windows and doors. That's not solving the owner's problems. If there's other issues that can be implemented to repair the problem to satisfy the conditions that the owner has a right to expect.
Yeah, so water infiltration, people feel water infiltration testing, people hear it and they think it's pretty simple, maybe spray a hose on it and see if it leaks or not. And it really is a lot, it's a complex scenario to figure out, how to test it, how to do it, and then do it correctly. What are the conditions, and how do you get an outcome that's going to be beneficial either to the new construction project or to fix an existing problem?
Exactly. You want to satisfy the problem out there, whether you're in a new job or whether you're doing a forensic examination, you need to address the problem.
So, we could probably sit here and talk all day. We usually go 30 minutes, and I know we're running a little long, but it's good stuff, and I really really appreciate it. So, you've been around the block a few times, as we all know. And do you have any closing wisdom you'd like to share with the listeners with regards to field water infiltration testing?
Wisdom? Well, I don't know if you call it wisdom. I think the one thing I'd have to encourage is first of all, for new construction, encourage the architects, engineers, building owners, or developers, encourage you to specify the testing properly, to get it in the original construction documents. Make sure you've got it in there so that everybody involved, all of the construction team, knows up front that the testing is going to be done. And remember, it's not just the window and door manufacturer. There's other people involved in this, including sealant installers, sealant manufacturers, waterproofing manufacturers, stucco contractors, siding, whatever. There's a team out there that needs to work together in order to satisfy these performance criteria. So let's make sure we get that right up front, right in the documents, and that everybody clearly understands what those requirements are before we start the job. As far as existing properties go, to those who are experiencing problems today in older buildings, my words would be, find somebody who is willing to spend the extra time to understand what the standards are and understand your problems and recreate your problems to solve your problems, not to go out and just start spraying water on the wall and throw up their hands and say, well, let's tear everything down and start over again. That doesn't solve your problem. Let's solve the problem, and it can be done in a fair manner.
Well, Will, this has really been great. Thank you so much.
It's been a pleasure.
Yeah, and I hope that we're going to be able to do some more podcasts as time goes on. I know that we don't have any shortage of topics, and particularly with your knowledge and experience, I know we always think we've seen it all, and then we see something else tomorrow that expands our knowledge. But I know you've really been out there. And again, thank you so much for doing this.
My pleasure.
So thank you for listening to Everything Building Envelope. Please subscribe to the Everything Building Envelope podcast at iTunes or Android outlets such as Stitcher, or visit everythingbuildingenvelope.com. You'll find show notes there, previous episodes, and bonus content videos and things of that sort. As an added bonus for visiting everythingbuildingenvelope.com, and Will was just talking about this, we're going to give away a specification guide for water testing. So this will help those who specify these things up front in determining, it's going to be like a little cheat sheet. So it'll help you with getting a good specification together for field water infiltration testing. So thank you for listening. Please tell your friends and colleagues about the Everything Building Envelope podcast. This is Paul Beers saying so long until next time.